Pranav Mistry.
Thank you, Rick, and good morning, everyone, first of all. So, I would say A for Apple computer, or we can say B for blogging, C for a CD-ROM drive. But I don't think anyone in this room learned English languages this way, at least not I. I learned A for a real apple, B for a ball, C for a chair, and those thousands and millions of objects around us, the physical objects. We all grew up with these devices like the chopsticks, or we can say knitting thing, a pen, a scale. And these objects have something different than the digital devices that we are using every day now. I don't need to call a call center when I buy a hammer saying that, oh, how to use this thing, something like that. But today I want to talk about one of these objects, which is this particular book. This is not any book. This is the book which was one of the first printed book. It was printed in 14th century. It was a Bible. And this guy, Gutenberg, he was a German inventor. He invented a printing press machine that printed this book. I think that this particular invention is one of the key inventions in IT industry, because that made the spread of information possible across the world. Right? The second big innovation came in IT industry, according to my understanding, was internet. The cloud that everyone is talking about, the information cloud that we have created. But the key problem still stays that how to look into this cloud, how to connect to this particular cloud. And okay, we have the solution. We found a couple of devices. Every day we are introducing new and new of those devices, right? If you look at that, we own 3 or 4 of them almost, and still we have issues with these devices compared to the thousands of real-life objects that we use every day. So this problem always stuck to my mind, that why? There is something missing. And I'm in search for that for a long time. And I started that exploration. So I'm showing you some of the exploration that I did in this line, where I can connect these two worlds, or maybe we can say make the computing experience more intuitive. I took this is a 12-year or 11-year-old project. I took my mouse, like a computer old mouse, if you remember, the ball mouse, took it apart, took 2 of these kind of mouse and made a device out of this thing. So you're seeing on the screen a device which is made of the 2 broken mouse, computer mouse. What this device can do, it can replicate the gesture that you're doing in real life. So here in this particular example, you're seeing that whatever movement I do with my hand outside in the real environment, it will be replicated inside the virtual world. It gives you some kind of intuitive interface to the information in some sense. So that was some of the very early exploration. Recently, I re-looked at the mouse project I did before, because I am very much surprised that even after so many years, 1964, Engelbert invented mouse. Still we carry mouse in our backpack. With the laptop, we get the mouse out and then use it. So I made this a small project where you have the interaction of the mouse, but there is no mouse. It's a virtual mouse. So you don't need to have a hardware. So you can click it, just put your laptop and start using next to any coffee table as the mouse, right? How does it work? It has a small infrared laser inside the laptop, and the camera will become a part of the lid of your laptop very soon. So in all these experiments, I was trying to make our interaction with these devices simpler, somehow trying to capture the essence of the real world, making a pen, using a paper, using real-life objects, because I think that world is more intuitive than particular this one. We don't need to have dummies like books for that thing to read how to. But then I thought one more time that I'm still trying to fight between this. The computer is our interest. But if you think carefully, we as a human are not interested in computers. What we are interested is the information inside. A person wants to know what is his flight timing, or he wants to know how the stock market is doing. He wants to connect to his family miles across. Our interest is in information, not in computing devices. So why should we at first place have that devices itself? And what we have done with this particular thing is we have confined the information inside these rectangular screens of digital devices. So my interest, long-term interest, is how can we integrate the information with the real world rather than having two separate worlds, digital world and physical world. Why can we not have one physical world, which is we already living in, and have the power of the digital world inside that world? So let me relook to, this is how we look nowadays, like we ever have two worlds. People started working on virtual reality, but still there is the same distinction between two worlds, mixed reality. So I'm showing you different approaches people have tried to get to the tabletop computing is one. Then people started putting silicon inside every object, a coffee cup with which can change the color or something like that. Smart objects. Then came the smartphones that made us mobile, but still our interaction with the physical world is too separate, right? So we are interested in these colorful circles, the bits. So I'm thinking that why can we not take those bits, the pixels, outside of that domain of the digital world and paint our physical world with those pixels. And to do that, the first thought that came into my mind was to put a projector on my head. Right? So I said, okay, I'll put a big size projector which will paint the pixel wherever I look at. And rather than just thinking in that way, I said, I will do that. So I took my bike helmet, put a cut on top of that bike helmet, put a projector over there. And now I'm going to walls and then I'm seeing, oh, pixels are running around wherever I'm looking. But the very next moment, I have this urge of touching them. I want to interact with them. I want to grab them because that's what we do in real life. If I'm seeing something, I want to take this thing. So I said, we can have a gesture input because gesture is a very natural phenomenon for thousands of years in the human life. And that's why I put a camera over there. So you can see the small camera, and I made this very first application which I can go to any wall and start drawing something, because that's, I can stop by that wall and say, oh, I want to draw something, I want to write a message to a friend. Then we made a smaller version of that. In Boston weather it's better because it's keep your head warm a little bit over there. But then later we have a different varieties or different, we can say, versions of this system, and we end up with a pendant version which is a little bit more stable than having on a head mounted. So this was one of the earlier version. The key component in the system still stays the same. It's like a small projector which is becoming as small as a button now, like as your coat button now. A camera which we are replacing with some different kind of cameras now, and a mirror system to guide the light where it should go. And the system is connected to your mobile phone, and that mobile phone doesn't require a screen because you can use any screen, right? So let me show you what the system can do. So it's a completely mobile system. I'm going to a wall, doing a namaste gesture that comes from my culture, and it starts the system. And now I can start using my hands to interact with that information. So you can see that I'm stopping by a wall and start using any computing interfaces. I'm checking an email or browsing through something. That's the first idea comes in our mind when we see this kind of interface. So in this example, I'm drawing on a wall. You must be seeing some kind of color markers on my hand. So in earlier version, we were using these color markers to guide the computer vision algorithms that how my finger is moving. The camera is tracking your hand gestures using that particular small color on top of your hand. And not only one finger, but you can track all 4 fingers. You can actually track 10 fingers, but we don't need 10 fingers in order to do some kind of gestures at the moment. So I can zoom into a map, zoom out a map. But you can do something more exciting. Now I'm going outside. This is the Boston Charles River. And I'm taking picture using the gesture of taking picture, right? This MIT main building. And later I can stop by any wall and start using that wall to browse this picture. I can send an email saying, oh, this picture to a friend, right? Manipulate those pictures. That is what we do with the information at the moment in our computing devices. But now, the limitation of pixels staying inside the screen goes away. You can start using anything as information sources. So in this case, I'm dialing a phone number. I'm getting lots of phone calls because this is my own number. So in this example, I'm going to this supermarket, or we can say I'm going to a bookstore, picking up a product. It finds out what product it is, the computer vision algorithms. In this case, it finds is what is the Amazon rating of this particular book, and project on top of that book itself. Or you can find out what are my friends have to say about this book, the reviews of my friends.
In 1943, Churchill gave a famous talk.
Of course, you can augment with sound. The New York Times has a review of this particular book.
Thank you, MIT.
This was Obama's visit to MIT, and I can see the live of what is going on inside. I cannot go inside as a security issues. In this particular example, the weather map which was printed, it was estimation, but now you can have the live dynamic information. So we like digital world because digital world has something different than the static world. The information can change, and if we can get that outside the digital domain, we can do lots of things. You can check your, oh, what is my flight has been delayed. You can augment people, right? So it is getting the Facebook cloud from my friends list and then finding what is up to right now. This is Boston Red Line, and I'm playing Pong game on the ground with my friends. And of course, you can do lots of other things. There are lots of applications coming up in the next version after then when we have seen this video. What we did in this particular example, I removed the microphone from that particular camera and made a clip out of that. So now you can pinch that clip to any piece of blank paper and start using that piece of paper as a computing interface, or as a tablet computer. So now my camera is tracking my hand movement, the projector is projecting information, and the sound of touch is getting as a touch data.
I am a wilderness explorer and tribe 54.
You can play games, right? In this one, there is no hardware sensor inside the paper. The camera is acting as a tilt sensor, how I'm holding my page or something like that. So the idea over here is that you can of course do all sort of normal computing, go back to your browsing and looking into your emails and stuff, but you can do something more exciting than the normal computing world has given us. Here you can see that I'm taking that information as a physical information source. I mean, I'm moving between the two worlds. Like how I want to work on a big size computer because typing is much better on a full size keyboard, right? Or you can do document editing in the traditional way. You can cut paste. In the old days, people used to do that on a newspaper, like printed something from here, printed something from here, make a document and say, okay, this is the final version. Or maybe I want to make some little bit changes over there. So let's change this value a little bit and now print this one, right? So this bit, after this particular video, we have so many new applications coming up, and there are lots of things that we have done, but we haven't have a video for this one. But let me show you some of the pictures that some of the sponsors I'm working with. So you can augment anything, like you can use the world of gaming, education. It's already your third coffee, don't drink much. So the applications of this particular approach is enormous, because when you are thinking of joining the digital world with the physical world, you can do lots of things. That is my personal thought. So I'm showing you a couple of the ones, some of them you've seen. When I was in Japan, this was useful for me because it can tell me that, oh, is it vegetarian or not, right? That's good for me at least. We are also right now interested in how can we have augmented reality, but not in the normal sense. So in this particular example, we are building augmented reality in a remote augmented reality. So a person who is novice, you can guide someone how to drive an airplane or something like that. Someone else can augment someone else's digital world. So there are lots of applications coming, and in this example, we are augmenting using sound. People cannot speak. So then it gives them a sound rather than giving so the person can do the sign language and the system will make the sentences for him and the system will speak on behalf of him. So we can do lots of stuff. One point I want to point it out over here, that in normal interfaces, normal computing devices, the limitation is the human limitation. It's not that we cannot make iPhone this small, but we cannot use it, right? But in this approach, the device can go as small as invisible. So this is one example of that. And the next big change that we are doing is we are replacing the camera with the depth sensing cameras in the next version, where you don't need to wear any color markers in your hand, and you have a bare hand and you can still have the gestures and whatever you've seen. So the last thought I would like to leave, and I want to echo in that thing, that the world that we have created is the product of our thinking. It cannot be changed without changing our thinking, right? So that is what I always keep this as my thought, and I will leave with this idea. Thanks a lot.